First, let me introduce myself. I'm Dan Vivian, the facilities manager for the city. I supervise the crew that does some of the maintenance on here, along with volunteers that do other work. I'd like to introduce John Lutz, Jason LeBrasser, and Brad Boink. These three probably know more about the fountain than I will ever know. They've probably forgotten more about it than I know. They put in a lot of time. John and Jason actually are employees of the city. They come up at night and run it, but I'm sure they put a lot more hours as volunteers than they do on the clock. A real quick overview, if nobody's been up here before, there's pretty much, I guess, three major components to the fountain. You have the pond and all the piping, the pump house here, and then down below is a speaker house. And then all together they perform. They're down in the pump house. There's 3 pumps that pump water. I believe 90,000 gallons over a program, I think is about that. They are 100 to 125 horsepower pumps and rated at 3,000 gallons a minute each. The electronics are run by basically a desktop computer and an Allen Bradley. And if you have any questions about that, that's all I know about that. Brad will answer everything about the electronics because that's way over my head. As you know, this is the 50th year. I believe the first time it ran was October of 1962. I think it only ran once, and then the next year was the full year, the first full year that it ran. There's like 1.5 miles of piping in the whole system. A lot of it's submerged that you don't see unless you walk up close. It is 50-year-old piping, so it is maintenance friendly, to say the least. But we haven't lost a night, I don't believe, since I've been here. I've been at the city a little over 4 years now. And between John and Jason and everybody else that pitches in and the guys and some of the local contractors, we've always been able to get it back up the day after not a catastrophe, but maybe a little minor setback. Most of the problems that happen at night, the people across the river don't even notice. It's the operators that say, oh, this valve's not working, or there's a blown diaphragm, or a ruptured airline, or you know, something minor like that. We've only had one real big problem last year. We ruptured a line that goes from the pump house into the pond, and that was a pretty major fix because it excavated a pretty good hole in the asphalt, but we had a local contractor come in and did his magic and got us back up that evening. So I guess questions will probably be the next. If anybody has any questions about function or maintenance or
maintenance costs, what's it cost us a year for maintenance costs?
If I had to throw a swag, maybe in parts, $2,000 to $3,000 in materials per year. Manpower is probably quite a bit more, a lot of man hours. It's never a simple fix. Even in the fall, when we take all the caps off the lines, you have to be really gentle because all these, the circular, what do you call it? The wedding cakes is what they're called. They have caps on the end that we take off every fall. Well, 50 years of taking a pipe cap off, you know, you lose a couple of threads every year, so you chase a few more. It has gotten a lot better with keeping the pond cleaner. We had our fab shop at the garage make some new screens for the pond. We've tried to be a little bit more diligent about cleaning it. When we do drain it and clean it, we don't just take out the sand. We pull the screens on the pit. We get sump pumps out and pump all the trash out of the bottom of the pit, and that way keeps it a little bit cleaner. And we pull the pumps apart every fall, clean the pine needles out and whatnot out of the pumps downstairs. We have rebuilt all 3 pumps. That's probably the most expensive repair besides that ruptured pipe that we've had to do, because the rebuild kits on these pumps, about $1,500 for a rebuild kit. And we've done all 3 within the past 2 years. So they're good to go for quite a while.
So what's the other issues with a 50-year-old system, or major issues that we need to be looking at?
The major issue would be the pipes that are submerged. There's spots, there's a section of pipe right in the middle where there's drain plugs on the bottom, and we have just temporary bands on them with rubber to plug the holes, but those holes probably started as maybe, I'm guessing, 1/4-inch drain holes, and now they're probably 3/4-inch drain holes. and you can see on some of the pipes, you know, we had the middle section of that cake break off earlier this year, and the inside of the pipes don't look real good. You know, it's a challenge even for when we have a contractor in here to fix a piece of pipe, because you end up going a little bit further back and a little bit further back until you find good pipe.
It's like under the ground, under the city.
It's kind of like our infrastructure in the town, where we start out with a break in one spot and we end up going probably about 50 feet further than we have to, because that valve broke and the next one broke a pipe down here as you go down. But my main concern, what I want to know is, you know, in the future we got to do something with this. This is an icon for us here, and we got to make sure that we keep it here. It attracts people from all over the world here for it. We just want to do a work session up here. I wanted to see what we have to be looking forward to in the next budget, or something that would be nice if you kind of give us some numbers or something that they can get together, or show us what we have to do, or tell us like we just did. I'd like to know more about it, you know. So we got a better picture when we go down and set our budget, that we can actually say this needs work, and we can dedicate some dollars to fix. You know, what the major fixes are, what can we do on ourselves, what can we, you know, what we have to do in the meantime.
And as far,
no, go ahead.
okay. No, is there things that we can do? If major stuff needs to be done, can we do stages? Or if you fix one end of it, the other end will look bad? Or can you, what does it, you know what I'm saying?
Looks wouldn't be a problem. The hardest thing to do would be to replace the pipe that's in the very bottom. And that would have to be, if you wanted to replace it, if you didn't want to replace everything at once, that would be the hardest, because you'd have to drain it, replace a section, fill it back up, unless you wanted to block a week out where no performances, or a couple of weeks for no performances during the summer, or try for an early spring or a late fall project. That could be done, you know, after shutdown, or
that would be more recommendable.
yeah.
Right,
Than shutting the program down. I don't think that's a thing that should happen, because, like I said, people come here.
Sure.
I mean, so they come from all over.
So if you have a long fall, you can,
Or an early spring like we had, you know, something like that would work out big for us.
Well, I can definitely get some contractors in here and see what the recommendations are.
I was just wondering, you know, because we got to lay some money out for it.
Sure.
Like I say, we know we have a problem. We know it's going to, you know, it's 50 years old and things need to be replaced. We just can't keep putting Band-Aid on it. It's the same thing we're doing with our infrastructure in town. You just can't put Band-Aids on it. You got to fix it. Let's do it right the first time, so we don't have to do it, keep doing it. We don't want to repeat it. We want to make sure it's done, and it's done for a long time, and it lasts for a long time for the people here.
you want to do it before there's a catastrophic break.
Sure. Well, maybe John or George, they might have a little bit better, Brad, maybe they can give a little bit more input of what they would think would be the best place to start.
I think you're really looking at late, fall, even if it means, cutting the September season short, saying, okay, let's stop at Labor Day, and then gives us extra time, September and October, to work on it, and then starting early in the spring if we have a light spring. It gives you time,
Right.
because no matter how hard you try, there's always something that's going to come up.
Oh, yeah.
And at least
Never
that way
quite as easy as
you're
you
almost
think
giving
it's
yourself a 4-month area that you can work within, weather-wise.
Are you thinking 4 months for a large reconstruction, or just for this core project of the underground central buried piping? That sounded like a couple of week job.
No, I'm just talking a couple of weeks for like one little section of pipe at a time.
Yeah.
I mean, if you're looking at downtime, how much downtime at a time can we tolerate, and what would it take to do a meaningful section?
You would probably be looking at a 2 to 3 month project by the time you get in there, cut the pipe out, figure out how to get pipe back in. When the pipe is out, it'd be best to crack seal all the seams in the concrete, because every year it takes a long time to get the ground saturated before the pond stays at a reasonable level. Yeah, it loses a lot of water.
All right.
We use gallons.
Exactly.
Yeah, there's no bottom.
Yeah.
I think is,
and it's impossible to seal it underneath the pipes.
I think it's just one council member. It'd be nice if the board itself would take a good look at this and give us a report back to us and tell us exactly some recommendations. And then, I don't know about the rest of you guys, but I think that'd probably be a great idea for us. Have the board work together.
I'm in.
I'm bored. What do you think, Board?
Well, if Jason would move into Grand Haven,
We're trying.
Well,
We're
well,
working on it.
I'm right across.
We got Mark here. You get Mark to work on it, so we're doing good with that.
One of the other items of concern for us that has come up just this year is the fact that the Dune Face is washing out underneath the pavement here at the fountain. And we've refilled it, what, 4 or 5 times? 4 times?
We put a bunch of broken concrete in there once, and now we're just filling it with sand. The problem is that the parking lot's kind of sloughing off towards the hill a little bit, and right where that gray car is parked, there was pretty significant washout right there when we had one of our torrentials this year. The guys at the garage came in and dumped a bunch of concrete and rock in there and tried to fill it, but the sand washed out from the rocks again. So we've just been
Yeah, if you walk
dumping
over and look
sand
at it, you
on
can see how it's just all the way down the hill, right to the bottom of the hill.
Well, you can see where the asphalt goes that
Yeah.
way, so
Yep.
the waterfall is going to go there. You
Yep.
got to stop the water from going that way. It's all another. We have to stop it.
Yeah, it's something I discussed a little bit with Bill and with Kevin.
we
And,
can kind of direction it, sand
That's to keep the sand from coming down
shove
into
it
the
off in a
fountain.
different direction, or
well, we might be
encourage
able
it
to put a
go-
curb along the parking lot and maybe slough it down the hill. You know, you can build a curb along here. You might have a little bit of a pool, but if you can get it to go down the asphalt here.
Right.
What I was hoping is tonight the council can get a good visual, so then as the board and the staff bring forward some kind of a capital recommendation, you've got a good mental picture of what it looks like up here and how it was faring in this fall. So, you know, maybe by the spring we can come up with some kind of a capital recommendation, a long-term investment plan, because I think the pond itself is also a big concern. You know, it's and all the asphalt up here, the drainage that you're pointing out can all be corrected.
Correct.
But it'd be a big capital project to do it. So there's several components. You got the sound, the electronics, the lighting, the software, the hardware, the plumbing, the drainage, the pond itself. All these things are in
Add up
need
to
of
it.
attention. So what order do you do it in, and how do you finance it? Well, that's what Jim's going to tell us.
Long term, you're also looking at the lighting. The lighting is very archaic by today's standards, and it's every one of those lights right there. There's a 747 landing light, is what is being used. So we're talking tremendous amounts of power being eaten up by those lights, and if any one of those lights burn out in the rack, it takes out the whole rack.
Whole rack goes out.
The whole rack goes out, and then you got to figure out which bulb's out, replace it, and then to get the rack back up and going, which is not a fun task. So new lighting is definitely something that you're going to have to look at.
Let's want to take a tour then?
But can it be, true light like LED or like weird light? Can you
Actually,
have
we
light
have
lights?
tested LED lighting up here with great success. You're looking at about a $10,000 expense to replace the entire, all the lights for the entire fountain. Switching from, going from 3 colors to 16.7 million
That would be fun.
$16.7 million or color?
colors. You're looking at about
That's our budget
$10,000
for this, Pat?
expenditure.
Colors that we recognize.
You're looking at LED wise, I ran the numbers on it, will burn for the entire fountain less power than 4 of those bulbs.
So they'll pay for themselves.
Yeah, and they're good for 100,000 hours of usage.
20 minutes.
All right.
How
All right.
many days a year we tell you?
Yeah,
That's a lot.
now, you're talking years of
So,
use out of the lighting.
And the advantage of the LEDs is they don't have to come out of the pond or off the ramps at the end of the season. They can stay in place year round. Whereas these racks, we've traditionally taken them off the hill and stored them away.
Oh, okay.
And then when we bring them back, then we have to spend a lot of time re-aiming them to get them back the way we like them.
Plus the LEDs are low voltage, and right now we got 120 volts
Running around where
running
water's
through all
going.
these wires, and
How about the water supply? Somebody comment on the water supply and the adequacy of the water supply up here?
The water supply comes out of that 1.5-inch pipe right there. City water. We just fill it up whenever is needed. Usually the operator comes up here, and when they start their shift, they'll turn it on and fill it up. Takes about 6 hours to fill it from empty to a workable level.
So the issues with fire suppression during our bigger events?
The fire suppression, if you see that white pipe that comes out of the ground at the end of the pond, that actually goes into the middle of the pit, which is right in front of the Peacock. They put that in. Then there's another, you can see the black hose that runs up the hill. They can hook that on to that and run up and get water to the top of the hill for fire suppression, or hook their truck up into that and pump the water down the hill. Pump it out from the pond. They use this as an emergency backup once they empty the truck, is what I was told how they would use it. It's bright out there. Yeah, as long as you don't have heels on. That would be bad. Yeah.
Takes some power, huh?
It does. We don't even have a meter that'll read that. Our meters only go up to 600. So we have to call an electrician anytime we have a problem with anything here. But we haven't had blown some fuses in here, but knock on wood, we've been really lucky. The guys,
So this here is this is pretty good in here, in this room here.
for the most part, yeah.
For right now,
I mean-
it would not be your primary concern right now to start out with.
No, the piping before that. Probably the worst, that pump is leaking the worst out of the packing, even though we put a new mechanical seal in it. Yeah, but it's still, once it runs, it stops a little bit more. We've put, but that one, just the shaft is wore down. This is probably the best of them. This one's just a drip, but that one, we had a new shaft machine for this one 2 years ago, or was it last year? I think it was 2 years ago. So that one's in the best shape than that one, because that one's newer, and then that one. But they all still, I mean, we don't have any major issues. There's one pump that if we start it and stop it, it won't restart. So the operators know when they start the program, they just start it and let it run. And if you let it run through the whole program, it never shuts down. But for some reason, I don't know if it won't start up. I don't know if it heats up the overloads to where it, that first initial start where it won't start back up. But
I'm going to go over the actual electronics part of the fountain for you. Really, it's broken into 3 pieces. We have the playback system. We have the Allen Bradley system. The Allen Bradley is what's controlling the valves and lights out there. And then we have behind you the audio system. So now, central place where everything starts is right here. 7 years ago, we switched over from using the digital audio tape, which was starting to get problematic, and also the DAT technology was, by the entire recording industry, being phased out. So all the equipment that was being used to create shows had reached its maximum point of obsolescence. So we got to a point where it was like, okay, what are we going to do? So to try and avoid those same issues that happen, everything was built upon using off-the-rack standard computer technology that you could walk right into Best Buy and get off the shelf. Now, the first step was we had to create 2 pieces of the puzzle. Piece number 1 was a programming system. My partner, Jim Swartz, developed the animated choreographer software, which is available out on the net and is free for anyone to download and be able to create a song for the fountain and submit it. And we've had submissions from all over the world for the fountain. And several out of a young kid in China, by the way, who's done some just amazing programming. Over the last couple of years, that has kind of slowed down a little bit, so we've got to kind of find a way to start getting people interested in it again. The nice thing about the programming system is it went from the days of when I was doing in the 80s where we had a text editor and we had to remember thousands of codes and type them in and go through this huge process. Original in the 80s, we were looking at about 200 hours for a 20-minute performance worth of time. Now, we're down to, you can do it about an hour a minute for programming. And it's all visual, so you don't have to know any codes whatsoever. Simply pull in a music file, start programming, and then submit it via email to the Fountain Committee. Now, that was the first component. Second was the playback. The playback took a huge departure from the old way of doing it. The old way, we had the digital audio tape, we had a 20-minute performance. And that 20-minute performance was always the same. From start to finish, there was no changing it. Once it was programmed, that was it. So since we decided we wanted to try and go to a computerized system, we figured wouldn't it be a lot more fun and also a better way to handle everything is to make it more of a jukebox style. So now there is no set show. Now we've got a catalog of about 240 songs. Yeah, somewhere between 200 240 songs that we can choose from. We can put them in any order at any time and click play. So if at the last minute we want to make a change, we can go in, change it. No problem.
That's where the ads in the paper saying this is the playlist for the night.
Yep. So all we do is we pull it, and we create playlists ahead of time. So we pull up the playlist, click play, ready to go. Now, then the playback system is sending the audio to the mixer, mixer to the amps. Then it's coming via a cable over here to the Allen Bradley. The Allen Bradley then is taking those codes, and then those codes are then turning each valve and circuit on and off from here. It's actually pretty straightforward. And it's a lot simpler now than it was in the early days. This computer right here has been up here for 7 years and hasn't failed us yet. And this is a really, really harsh environment up here. Yep, HP system. This is actually a retail hardened system, so this is not an off the shelf. This was intended for like kitchens and really bad environments. So that's why this guy is up here. But 7 years ago, it was still under $1,000 for this computer with the monitor. So reasonable. We're looking at winter project for this. The computer itself is fine. The hard drive is got 7 years worth of usage on it, and for any computer, that's pretty good. So we're probably looking at a $100 expense to replace the hard drive, reinstall the operating system and the software on it. Pretty minor. But the computer itself is top shape. No issues whatsoever with it. But with all these electronics, there is something that really needs to be done. Two things. As you can see up here, the operator has the ability to look out at the fountain at night. This is a blessing and a curse at the same time, as I was explaining earlier. Because what happens is those windows aren't tinted. It becomes a greenhouse in here. It is nothing for it to be 100+ degrees in this room in the summer. So the windows that are up there really need to get tinted with some type of reflective tint so all that isn't coming in. The other thing is the air conditioning that's up here. Once again, this has been up here 7+ years. It's really seen its better days. It can't keep up with the amount of heat that's coming in. So we need a better air conditioner. Not a huge expense. It's just something that would make the room a lot better, because the better we can keep the humidity and the heat down here, the longer everything's going to last. The first sign of really starting to have problems with the heat has been the amps. On 4th of July, we actually blew out an amp. It smoked and filled the room with smoke.
And then half of the fountain ended into the show.
Yep. So now no one across the channel knew it because we have a lot of amps there, but it was the first sign of, okay, we really need to look at what we're going to do. And the redoing the windows with tint and an air conditioning is a whole lot cheaper than replacing an entire rack of amps. Because eventually they're going to go if they keep getting this kind of strain. Once again, those amps are quite old, and the older they get,
They're about 15
Yeah, about 15 years old, which is amazing for an amp. Everything up here has been performing stellar, but we got to look at how are we going to keep things from failing as it gets older. And it's not expensive stuff, it's just some real minor things that need to be done. You know, this equipment right here, this can handle the heat. This is the Allen Bradley. That's an industrial piece of equipment. It's intended to be in a factory, so it can handle the heat. It's just some of these other things that aren't quite up to that load.
Logic in it needs to be cleaned up. It has old codes from old days and everything still programmed in there. So somebody needs to go through it and go through the program.
Yeah, we need to, the master programming for the Allen Bradley really needs some updating. There's some glitches and some bugs in it and things that need to be fixed. The big question right now is finding the source code for it. We don't seem to know where it is at this particular moment. It's got to be in a city archive somewhere, as best as we can figure out. Now, the inside of it, as you can see, it's pretty basic. And I don't recommend putting your finger in there at all. But here, let's actually take a moment so you can see the process here. It's going to get loud a moment, but I want you to see what an operator does, how we get it going, set up. And the first thing, anytime I'm up here with someone who's never been here before, they go, I didn't realize the water went up that high. And it is much higher and grander than anyone thinks it is. So we're actually going to pull up a show, play it. We'll start the whole process so you can see it from start to end. All right, first up, we're turning on the hydraulics. The hydraulics are for the sweeps. Our air compressor. Notice 00 means the Allen Bradley's ready for us. All right, now let's start our pumps up. I love that sound of it going up. All right, we're going to wait just a moment here. All right, at this point, we are ready. So I'm going to click play. And you'll notice we'll have codes going across here and codes coming across here. So as you can see, it's taken those codes pretty quick. 7 years ago, when we switched to this computer system, we went from the fountain being able to handle 6 codes a half second, so 12 a second, to 256 commands a second. Now, there's been the argument of the fountain can't pull that off. You know, for being 50 years old, you'd be surprised at what the fountain actually can pull off. When we were doing our tests, we were able to push it way beyond what we thought we could actually do. The song after this one, Jack Sparrow, when we go up and listen to it and watch it, that particular song has more commands than 5 of the classic shows combined. So that 5-minute song has more commands than 5 of the classic shows put together.
Well, yeah, I think we're pretty much wrapped up unless anybody has any other questions for anybody here this evening.
No, I just want to say thank you for the tour.
Well, thank you very much.
I think it was very informational. It helped us a lot. It showed us what was going on, how it operates, and I'm sure, I don't know if John's been up here, seen it operate before. You know, Denny's been here.
Not since the
60s,
I think. Late 60s, early 70s.
I thank you for the opportunity. It gives us a chance to look at different things that we want to do and how we're going to look at it totally different than what we would otherwise. So
Great.
That's all I want to say.
Well, we'll start working on the mechanical stuff and present some stuff to council here, hopefully in the future.
No, thank you, Dave.
All right.
Thanks.
Yep. Thank you. Thanks for coming.